Pre-calc 5.2, day 2. We're going to talk about even and odd properties of sine, cosine, and tangent. Don't read that first sentence yet. Basically, I want to go to this line first that I got in red. I got x cubed, and I say, hey, that's odd. I go to x squared. I call that even. We had a rule, guys, back in chapter 3, I think it was, when we were graphing polynomials and all of that. And we had some definition of what's considered an odd or even function. Do you guys remember what that was? Do we remember why x cubed is odd, x squared is even? What made that work? What's that? Why? Right, something with negative x. For an odd function, if I was to put in negative x, what happens with odd functions? Think of what happens when I put a negative x into x cubed. It becomes negative. Isn't that the same as the original function, but the opposite values? So it's the opposite of the function? That was their definition of being odd. Is that when I put a negative value in, I get a negative of the same value I put in as a positive? And then even, when I do the same thing for even, what would happen with a negative? It just goes away. Negative f of negative x is equal to the f of x. The same function, original function. So now we'll read up above that sine, cosecant, tangent, and cotangent are all odd functions, while cosine and secant are the even functions. Well, it should make sense that if sine is odd, then cosecant is also odd. Why? Because they are what to each other? Reciprocals. Tangent and cotangent. Sine and secant. They are reciprocal. So if the big three, the sine, cosine, or tangent are one way, then the reciprocal are the same way. Okay? So, looking at that, look, sine of a negative t, a negative angle, is the same as the negative going out, leaving you with the opposite of sine of t. Cosine of a negative t is the same thing as just cosine t. Tangent of negative t is the same thing as the negative tangent t. But why? Why does this seem to work? This is why. Let's give a t value here like pi over 6. And a negative pi over 6. They would terminate on the unit circle at those 2 points. Could you guys tell me what the points are for pi over 6 and negative pi over 6? What are these points? 30 degrees, guys. Square root of 3 over 2, comma, 1/2. Second point. Yes, square root of 3 over 2, comma, negative 1/2. Now, the x is really which one? Sine or cosine? It's the cosine. So, if I go 30 degrees, or negative 30 degrees, or pi over 6, negative pi over 6, I still have a square root of 3 over 2. Square root of 3 over 2. Because I'm in the positive x range. But look at sine. Sine's your y value. It becomes 1/2 or negative 1/2. But 1/2 is still the base number, right? Sine of 30 is 1/2. It's just the opposite. Tangent will work the same way because tangent is the fraction of those two, right? So when one's positive, one's negative, it ends up with a negative. That's why it's working that way. Any questions? So yesterday, not yesterday, but on Friday, I gave you this problem here. And I asked you, can you evaluate tangent of negative pi over 3? What we did is we graphed it, right? We graphed it, and then we used tangent to figure out, using the reference angle, that it was negative square root of 3 because it's negative square root of 3 over 1. I had to graph it. I had to go to the fourth quadrant to get this answer. But if I can use the even and odd stuff, I don't have to go there. I can stay in the first quadrant. In the first quadrant, everything is positive. So that means that the tangent of negative pi over 3 is equal to, using even or odd, tangent is what? Odd would become the negative of tangent of the positive pi over 3. And if you can draw your reference triangles, or if you actually knew what pi over 3, tangent of pi over 3 is, you can be like, oh, that's just the opposite of square root of 3, which is negative square root of 3, which is what we had stated above. So there's multiple ways to get our answers. We can make a graph, we can make reference triangles, we can use even and odd properties to make it work for us. Any of these options are good to go. Can you do sine of negative pi over 6? Sine of negative pi over 6. I'll make it a little bit larger here for you. So, sine is even, odd? Odd. So the negative gets to go out. And it's the same thing as sine of pi over 6. Wait a minute, we all should know off the top of our head what sine of pi over 6 is, and that is 1/2. So the answer is negative 1/2. Done. Not too bad, is it? Kind of like that. What about cosine of negative pi over 4? Cosine, though, is it's even. So the negative disappears. You can ignore it. So it's the same thing as cosine of pi over 4. And I would also say that you guys, every one of us, should know the sine and cosine and tangent of pi over 4. Square root of 2 over 2. Done. So in this one, we're going to talk about the really basic identities. The ones that you guys should really know off the top of your head. We need to understand. Well, first of all, I added some more in here. Notice that they only go with cosecant t is 1 over sine t, secant t is 1 over cosine t, and cotangent t is 1 over tangent t. I also like to add to my list of identities the fact that sine can also be written as 1 over cosecant t. Cosine t can be the same as 1 over secant t, and tangent t is the same as 1 over cotangent t. They don't have that listed here, but I think it's very useful to know because as part of our problems, you're going to either have to find their values or you're going to have to write one in terms of the other. And so you're going to need to know what those connections are. It's kind of like when we do the negative exponent rules. A lot of times books just say, hey, if you have a negative exponent on top, you bring it to the bottom. They ignore the fact that sometimes you end up with negative exponents on the bottom that you need to bring to the top.
Just a given.
Yeah, they kind of say, oh, okay, you should know this.
Yeah.
But I like to list it because that's why it's a little bit less thinking we have to do. Then, we also have these three, and these three are big. Actually, one of them. This one right here is the biggest one that you have to worry about. This is the one that I want you to focus on. Why? Why do I say if you're going to remember any of those, that's the one you have to remember? There's a reason. You guys done this last year. Well, it's a squared plus b squared equals c squared, or isn't that just the formula for the unit circle? Isn't the sine value the y? The cosine value is the x? That's just x squared plus y squared equals 1. That's the unit circle. That's the unit circle equation. But why can I only have to remember this one, and these two will follow? You don't have to remember these, you could build them. What happens if I divide by sine of squared of t? If I divide everything by sine squared t, what's sine squared divided by sine squared? 1. What's cosine squared divided by sine squared? Cotangent squared. And 1 over sine squared is cosecant squared. I can build the other two by dividing by sine or dividing by cosine, because sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1, and 1 over cosine squared is secant squared. So you can build the other two based off of sine squared plus cosine squared equals 1. The Pythagorean identity, okay? You're going to need to know this. The next one they want you to do is find all the trig functions from the value of 1. You guys did a little bit of that earlier, but now you have to potentially solve for another side and a couple other things. You're given that cosine is 3/5. Cosine t is equal to 3/5. I want the other big three. Sine of t, tangent of t. Now I need to find the little 3. Cosine is secant t. Sine is cosecant t. And cotangent t. Which one do you know right now? Boom, like that. Secant, which is 5/3. Just take the reciprocal. The other 4, what are they? A little bit trickier, isn't it? This is what I would suggest. Draw yourself a triangle. What quadrant am I in again? 4. I'm down here like this. Boom. Here's T. That's angle T. Do I care what T is? No. Don't care. But I know something. I know the cosine of that value. Cosine of that angle is adjacent over hypotenuse. Wait a minute. That's a ratio of adjacent to hypotenuse. So adjacent is 3. Hypotenuse is? Can you solve for the third leg? It's 4. Why do you know it's 4? It's a squared plus b squared equals c squared using Pythagorean's theorem. But it's not 4. It's a negative 4 because I'm going down in y. So now if you want to know the sine is opposite over hypotenuse, which is a negative 4/5. Tangent is negative 4 over 3. And the others are just the reciprocals of those fractions. You guys can figure that out. It's not so bad, right? Now we're going to have to do a little bit with our Pythagorean identities and understanding some stuff on these identities. The next problem says, you ready? Write tangent of t in terms of cosine t only, where t is in the third quadrant. So we are over here someplace. Can you change tangent of t to something else only in terms of cosine? So what are you guys thinking? How about math? How about this? Any ideas? What is tangent? Sine over cosine. So we would say, hey, that's sine of t over cosine t. First of all, guys, think of this. Tangent in the third quadrant is what? It's positive, right? Because sine is negative, cosine is negative. Those are both negative, which forms a positive. Hey, I've got a cosine. Are we done?
No.
No, because sine's not a cosine. How can I get rid of sine to make this a cosine or get rid of it? Both sides. Well, first of all, since we're trying to change it, I can't do something to both sides of the equal sign. This is just kind of saying that they're successively equal to each other, right? With the cotangent. Like what? Sine over sine. So remember, what do we do to the bottom? We have to do to the top and vice versa, right? So if I wanted to get rid of sine, maybe multiply by the cosecant or 1 over sine. Would that be okay? So, I mean, legally, this would be okay, right? But, okay, I get that. That's gone. But now what happens? It becomes 1 over cosine over sine. Do you see that? This just brings the cosine to the bottom, or the sine to the bottom. That doesn't work. That still introduces sine still. It doesn't get rid of it. To the tangent. You just want to multiply 1 over sine to the tangent?
No, because why is going to both sides?
Because it's like me asking 25 over 5 is equal to dividing, divide by 5. Divide by 5. And so this is equal to 5 over 1. There's an equal sign, but it's only because these two things are equal and not because I'm actually having an equation going. So I can't do things to both sides. Does that make sense? No, she wanted to. She asked, why didn't I multiply 1 over sine to the left and to the right of the equal sign?
What? Can you just change tan to sine over cosine?
Yeah.
Yes, we did. We got sine over cosine. But I still have a sine.
So what are we trying to?
Get rid of sine. I only want cosines. Because that's what it says.
Find it in terms of.
Yes, in terms of cosine.
Okay.
T. Any of these things have a sine and cosine linked together?
I'm looking.
The first one, sine squared t plus cosine squared t equals 1. Can I solve that for sine? Sine squared t plus cosine squared t equals 1. If I solve that for sine, won't sine be in terms of cosine? Yeah. So subtract a cosine squared t minus cosine squared t. Sine squared t equals 1 minus cosine squared t. And I have to get sine by itself, right? Because I want to substitute for sine. So I need to take the square root. Don't forget, though, I'm solving. It could be a plus or a minus, right? Okay. So sine's out. I substitute 1 minus cosine squared t all over cosine t. We're done. Or are we? It's only in terms of cosine. That's fine. But I didn't write something. Plus or minus. Should I write a plus or a minus here?
Where did the sine and t
Question? Tangent of t is equal to sine over cosine, which is also equal to plus or minus the square root of 1 minus cosine squared t all over cosine. The question is, I don't want a plus or a minus because I'm in the third quadrant. So the question is, tangent, we said, was positive, but sine and cosine themselves is negative. That means this cosine will eventually give me a negative answer, yes? But cosine in here, which could be negative, ends up being positive because I'm squaring it, right? So the top is going to always be positive, the bottom will be negative. That ends up giving me a negative tangent value, which can't be. So I actually need to actually choose, whoops, a negative value. Because I need this negative to cancel with the negative of cosine that will be there when I plug values in the third quadrant, right? So therefore, I can get a positive value, which is tangent of t. It's a small taste of what's coming up in chapter 7. We will definitely get there. And we're going to spend a lot of time in identities. Your homework for day 2 is page 426, 51, 57, 59, 61, 63, 69, 73. Have a great day.